So this is one edge and this is another slant edge. They meet at one point called as apex. So this triangular face and this is apex and base. So with this basics we will start a problem. So let's say pyramid. For pyramid, as we discussed, if it is a square pyramid, let's say this is a center, means I can draw the axis. This point is apex, this is axis, and this is base, and it consists of this slant edges. If it is resting on corner, you can see. So basically, this is a slant edge. This is slant edge, and this is axis height. So now we'll see how to draw a square pyramid when dimensions are given. So we'll be having a problem resting on HP only. So there will be two possible cases: a square pyramid resting on side and square pyramid resting on corner. So what are the possible cases for a square pyramid or all other shape also? So we'll be discussing square pyramid, but the concept of this pyramid as a square pyramid, maybe first stage and second stage, they are applicable to all. Means the same concept may be applicable for pentagonal pyramid, hexagonal pyramid, triangular pyramid also. Fine. So first stage, I'll write one question as of a square pyramid. The question is, square pyramid side of base 30 mm and axis length or axis as 60 mm, resting on HP on one of its base side. So very simple, first stage as mentioned, square pyramid side of base 30 mm, axis height 60 mm, rest on HP on one of its base side. So first stage is as mentioned, this is a square pyramid, okay. So this square pyramid is resting on HP, so on horizontal floor, that is HP, horizontal plane. So this is resting here, dimensions are given, the base side, it is resting on HP on its base side 30 mm. So this dimension is 30. So base polygon as a square, these dimensions are given as 30. Next, so in top view you need to draw the square with these slant edges, red color lines, right? Whereas front view is this triangle. But how to draw? For this they have mentioned axis height is 60 mm. So first stage I will draw with the given dimension resting on side. So we are going to follow resting side on this side, means on right, okay. So this is a side, let's say AB. So AB has a resting side. So I will draw like this. First stage front view as well as top view. In second stage it may be inclined like this because we are having resting side on the right. So we are keeping this side as resting parameter, right. So second stage inclination will be with HP according to the given value. So first I will draw the first stage. So I have drawn ABCD as base polygon, right? So I need to join the slant edges. So find out the center and join the slant edges. So draw base A, B, C, D, find out apex as a center O, join the slant edges. This is top view, right? Now, how to draw front view? Axis height is given, so I will project this point. I will draw axis. And axis height is 60 mm. So on this, I will mark this distance, let's say, as apex O, with this distance as 60 mm. This distance is 60. The side of is 30. Now project this AB and CD and join it. This point will be AB. So resting side is AB on the right. This is CD, opposite side. Now first is done. So this is the given data. Square pyramid, side of base 30 mm, axis 60 mm, rest on HP on one of its base side. So I have drawn a square side 30, side on the right. So it is resting on side AB, 30, 30 as a square. I have drawn center as O apex. Join the slant edges OA, OB, OC and OD. Second parameter to draw the front view, axis height was given. So this distance was 60. So on axis height from this I have marked 60 mm and then just project this AB and CD in the front view. You will get front view in the first stage. Now this is a first stage resting on side. Now in this lecture we'll be focusing on only first, keeping first stage constant. We'll see a different combination of second stage, so that will ensure first as well as second stage marks up to 8, means first and second stage. So we'll see different combinations of second stage. So let's say now, I'll say first, if base is inclined. So a base is inclined at 40 degree to HP. So first condition, base is inclined. So this is the case. Let's say this is the case. A square pyramid, this is square pyramid resting on HP on its side, axis height was 60. So I had drawn first stage. Second stage, it is mentioned as it is resting side on this side. I'm going to incline like this, keeping this side as always on XY. So now they have mentioned as second condition, angle made by this base polygon with HP. How much it is? 40. So this angle given is 40 degree. So this is second, always first stage is resting on HP, second is angle made with HP or the combination which is related with the HP. So second condition, angle made by this base polygon with HP. So how to draw the second stage? See here, now this is second condition. So we need to draw this front view as well as top view. We are going to follow change of position for second stage. So angle made by base polygon. So it is ABCD as base polygon. So ABCD this. The angle given, let's say this is, I'm keeping AB as on resting side on XY. Base is inclined to HP, that is 40 degree. So I will draw 40 degree line at this side. This is the angle 40 degree, that is angle made by base. Take this distance in compass AB to CD. AB to CD in compass from AB, mark here. So I'll take this distance and I will mark here. Let's say this point is C comma. Similarly, we need to take this point O from this view. So take a distance AB to O, mark from AB one arc. Same, take a distance CD to O, mark from C. Join it. This is O. So second condition was angle made by base BCD. So I have taken this base angle as 40 degree with respect to HP. I have drawn this line 40. I have marked this ABCD distance AB to CD here. Then I located O point. Next, take a projections from front view as well as from top. This is apex point, so I'll take a projection of apex too. Right? So just locate the point. This point is D, projection of CD. This point is D. This will be C. This is A, B, O, apex and O. O. Now what is our rule? First, outer edges are visible. So first I will join all outer edges. OB, BC, CD, this one and next. Observer position is here. So from this we need to draw hidden lines. So what is rule to draw hidden lines? From observer farthest point is AB, right? So this is point A and this is point B. So line passing through farthest point will be hidden lines. So I will draw this AB line hidden. Got it? So very simple case, when angle made by base is given, I need to take 40 angle, take this distance, accordingly locate O, take a projection and draw this view as second stage top view. Rule is for this view, outer edges this as O to B, this are visible, so continuous thick line. From this line passing through the farthest point is AB, so AB, so this line AB as hidden lines, which is not visible in the corresponding view. So that is second stage. This was your first condition. Got it? Yes? Any doubt? No. Now, this is one simple case when angle made by base is given. So any other cases, combination of second stage, that we'll discuss now as of next condition, second problem. Now consider instead of base, angle made by axis is given. So that will be our second problem. So here also you can show the axis. It is like this. Take this distance. You can show axis here also. So this is the axis which you can show for previous problem as it is. Just take this distance, mark here and take a projection. So you can draw axis in this view also. Now I will change this problem as second condition. If angle made by base instead of this, now if angle made by axis is, will take 40 degree, same. to HP. If angle made by axis is 40 degree, so what will be changed in the second stage? This is axis, so this angle is 40. So absolutely when I extend it, this angle will be again 40. So I need to calculate, or you can take directly, I need to calculate angle made by base. So what should be the angle made by base? Now see it. Second type or second condition for this. This is a square. First condition is constant square pyramid resting on its base H. It is inclined to HP, so that is something kind of second condition may be given. Now we are saying it is inclined to HP, so that axis is making an angle. So axis is what? This apex joined with center of base, right? So that is axis. So when I am going to extend this axis as imaginary line on floor on HP, the angle made by axis is given as 40 degree. So what should be angle made by base? Is it 90 minus 40? 50. So that should be angle made by base. So how that we'll discuss. See here. If I draw this view as previous problem, this point is AB, this as CD. What is axis? This is axis. So if this is angle made by axis with HP is given, is it 90? Then what should be this angle? 90 minus angle made by axis. So if I say angle made by axis is theta, then what should be angle made by base? 90. So with the same logic you can solve this problem just like previous problem. In previous problem we are taking the angle as angle made by base 40. So it is again same type with value is changed as for this problem. What is angle made by base? 50. So here I can say angle theta made by base will be 50 degrees. Got it? So now you can draw same problem as it is just like previous case. Only change is angle is now 50 degree. So angle made by axis in case of pyramid. In case of pyramid, angle made by axis and angle made by base, the relation is 90 minus theta. If I say angle made by axis is theta, then angle made by base will be 90 minus theta. The logic as we just wrote it. Now, other conditions that are very important which we'll discuss now. Now, consider this is second condition given as a different positions of apex. So first is resting on HP on its side. So now tell me what is a minimum position of apex? Minimum position of apex when it is inclined to HP. So second condition is similar to prism. We had two cases, a prism resting on face and prism resting on edge. So whenever question is a prism, let's say a square prism resting on rectangular face, we take First condition, resting on side. Now same condition, if the question is apex, it is inclined to HP, so that are simply apex is at minima. Apex is at minimum means the inclination, keeping this as resting side, inclination is so that apex position is minimum. Minimum, that means simply like this. So it is resting on face. So when I say apex for pyramid is at minimum position, that means it is resting. Now we'll say the first condition, this resting on side, apex is at minima, that simply means it is resting on this face like this, right? First condition this. Second, apex is at minima, so its minimum position when it is inclined, like, so it should be on XY since it is on HP, right? So I will draw a second condition. Apex is at minima, that means it is resting on, this is second condition. What is the meaning of it? It is same as resting on face, right? The meaning of apex at minima as well as resting on face for this case when it is resting on side is same. Now how to draw second stage? Means this face is ABO. This is a triangular face. This is now resting on HP. So I will take this is AB. Take this length AB to O, mark from AB. Let's say this is a point. Now take AB to CD distance, mark one arc somewhere here. Now take AB to O distance, mark from O somewhere here. This point is C. Take a projections A, B, C, D and O. So this is point O, O projections, O projection. Similarly locate this point is A and this is B. This point is C. This is point projection of D, D. So this is D and C. Now join the edges, outer edges are then observer is here. So line passing through, say farthest is you can see as AB to O, right? Rosa rule, outer edges should be visible. So as you know for this problem, when it is resting on face like this, okay, resting on face, you can see base complete all the four lines. Even it is farthest, but you can see as outer edge. Got it? So I need to draw all these lines visible. That is done. Locate the axis. Take AB to this distance. Let's say this O dash or O. Take this distance. Mark here and draw the axis. Projections of this axis you can take in the top view also. So this is axis in top view. Got it? Second condition, when apex is at minima, the meaning is resting on face because first stage was resting on side. Got it? So what is another possible case as third condition? for this. Now next I will write question on board as of third problem. It is inclined to HP. It is inclined to HP so that highest point of base is 20 mm above HP. Highest point of base is 20 mm above HP. Now first condition this, resting on side AB, it is inclined to HP so that highest point of base. So which is highest point of this base, right? So in second condition they have given the position as of locus for point this, as you can see in front. So when I am going to incline to HP, so that highest point of base, so as of square, if it is resting side is CD, what is the possible case for highest point? Opposite side, always. So opposite side is the CD. So in second stage it is inclined to HP so that the highest point as of CD locus is given, that is 20 mm. Got it? So now how to draw and when the locus is given at 20. So first I will locate this point at C, D because AB point. This is the highest point of base CD. So I will locate 20 mm CD point. Then next take the distance CD to AB. Mark on X1. Next, simple. Take the distance, mark one arc here. Take this distance, mark another arc. Rest procedure is same. Take projections and complete the view. Now, as of you need to join these edges. As of square pyramid, in all this previous problem also, let's say it is inclined to HP, right? It is mentioned this locus as 20 mm for this point. So when it is inclined, what you can see in the top view, these two edges, right? Top view. Now what I will do, I will just join, let's say this point is point A, B, C and D. Here the observer position is this, the line passing through nearest point, let's say O as outer edges, this I have drawn continuous line, this AB, so this I can draw this as well as these two edges DO and this, they are also not visible. So I need to join this with this hidden lines. Because it's logical, when the angle is given in corresponding view, we are not going to see corresponding slant edges. Now this is condition when locus for this point CD is given. Got it? Any doubt in this? Now we'll see next condition as apex at minima. We saw this is the condition when apex is at minima, that means it is on resting on face. What is another case when apex is at maxima? So can you imagine what is a possible case when apex is at maximum? I'll just write here a sentence. Next one. You just note down the things as questions. Next is apex is at maximum position. Apex is at maxima. So let's say this is condition first stage, this is a phase. Apex maximum position, we are keeping first condition constant resting on side. So it is inclined to HP so that apex is at maximum position. So can you imagine what is the maximum position of this apex when it is inclined to HP? Or is it the same case which I am showing on HP? So I'll show you with the diagram. You can see here the first is resting on HP, right? Now it is going to incline. Logically when it is like this, it is not the maximum position of apex. So what is maximum position means the apex should have highest distance from the XY line, that is from HP. So this should be the condition. You can see this curve. When this face is exactly perpendicular to HP, then apex is at maxima. Now how it is so? So the logic behind is very simple. If you are not able to imagine, I'll tell you with the simple circle method. Let's say I'm drawing here same first stage. Tell me, what is this point? What is maximum position of apex? That is our question, right? Keeping this AB on XY. Yes, AB is the resting side. So what I will do, I will just rotate this AB so that this ABO becomes vertical. Means I am just rotating this. Then ABCDO, it will be somewhere like this. So this is actually the circle. And highest position is always when corresponding face is exactly perpendicular. Got it? Now you can see if it is that's why I had this slightly enlarged dimension of prism. First you see the apex and now observe the position, keeping this is fixed. This is slight arc. When this is exactly perpendicular, apex is at highest position. And then it will again goes towards HP. So I need to have highest position of this O point. That means simply this edge face should be perpendicular to HP. The logic I explained like this. First stage, when it is like this arc which I have drawn as center of AB, because why center this side? This is fixed. So I am going to rotate with this point like this. So logically this O will shift here, and that is again it will decrease. So this is the highest position of apex. Got it? Is it clear concept? Why I have taken apex perpendicular means particular this face perpendicular, because I want apex is at highest position. Now I will draw second stage with the same logic. Now this face ABO, it should be perpendicular. Take CD, mark one arc, AB to CDO distance, mark another arc and join it. This point will be C. Same now. Rest of the procedure is simple, and as it is like previous problem, just take a projections. Now in this, the difference is this is point O, A, B, C, D. And you can see this also, right? So this is second stage stop. As projections of OAB are on the same line, I'll get ABO on this same projection. So this is the case. So you can see these edges in the top view. When it is vertical, you can see these two edges in top view, right? So I have drawn these two edges, continuous thick as visible lines. Got it? Now we saw apex is at minima, apex at maxima, locus of highest point of base, that is CD. So similarly, locus for apex can be given, which is again same simple case. We saw angle made by axis, angle made by base. Similarly, we may have other cases like similar to prism, where we had two cases, prism resting on its rectangular face and prism resting on its longer edge. Now here also we may have two problems as question is square pyramid, side of base 30, axis 60, resting on HP. Instead of it, they'll directly say axis 60 mm and it resting on one of its triangular face. So it is resting on one of its triangular face. So it's similar to one previous case. When I say apex is at minima, that means it is resting on triangular face. So it's same problem. But now I'll change slight. Instead of apex as minima or it is resting on face for pyramid, it is one and the same, right? So apex is at minima, that simply means it is resting on face, but it may be like this also. It is on corner. See, this is the position I have taken this now, corner. And in this case also they may say apex is at minima. In that case it is not resting on face, it is resting on edge. So that depends on first condition which is given. Got it? So if it is simply said apex is at minima, then they should mention as a question detail resting on side or corner. If they are saying resting on slant edge for pyramid, for prism it is resting on longer edge or simply edge. For pyramid, the question is it is resting on one of its slant edge. So resting on one of its slant edge means like this. So I need to take resting parameter in first stage as corner. Now we'll take slight change. Instead of this resting on edge or side, base is perpendicular to HP. Base is perpendicular to HP means what? Second condition. So this is a square pyramid. First stage is resting on side. Let us say resting on side. It is inclined to HP so that base is perpendicular to HP means like this. It is not resting on face. This is the case. Face means like this. There is a difference between this case and this case. Got it? So now I will draw this stage when I am saying a base is perpendicular to HP. So that means angle is 90 for base. So what is base? AB, CD. So keeping AB here, take 90 degree as perpendicular base. Take this distance AB to CD. Mark from AB. Take this point as CD. Next, AB to O and CD to O. You just draw two arcs. right? This is point O. Now take a projections. It is again simple, same as it is like previous problems. O, this point is A as well as D, and this point is B as well as C. B is C projected because the projections of all these 4 points on a same line. You can draw the axis. Now, what is same solution? What is another problem sentence for same solution? This is same. Base is perpendicular to HP. Can you think any other sentence for same solution? Yes. That is, axis is parallel. Axis is parallel. You can see this axis is parallel to HP. That simply means base is perpendicular. So meaning of both is same. Yes, got it? Now, any other sentence for same solution about this side, CD. Same. This is first, let's say second and third. What is CD position? Is it maximum? Because if I consider this as a center and if I draw a circle or just semicircle, from resting side, let's say this is first condition, as from resting side AB, this is, if I draw AB to CD as one simple circle, this should be highest position, right? So I can say opposite side or edge, opposite side or edge to the resting edge or resting side on HP. So resting side on HP is AB. Its opposite side is CD. Is at maximum. So these are different 3 questions formation, but the solution is same. That means either axis is parallel or the CD is maxima or base is perpendicular. Or maybe one more possible case, as they may give you this locus for apex, so that automatically you will get the base perpendicular. So that is again a simple way to give the locus for any point, either apex or for CD. That is simple. So this is a different formation of same solution. So you should be a very logical for the solid. Apex parallel, apex or this axis line passing through this apex O, that means center of base and apex, that is axis. So it is parallel to HP.